At my business, I have a Frigidaire stove that isn't heating well at all. We've already diagnosed all the other possible problems, and we have determined that the board is likely bad because when our tech jumped out the control board and ran the heater directly, it began to work. Oftentimes on a Frigidaire stove like this, you're going to hear the control board click constantly when you're trying to run the bake, but you won't get any heat, and that is a major sign that the board is actually bad. So I want to show you how to diagnose and fix the board itself today. We're skipping most of the parts of disassembly since we want to focus more on the board itself. Make sure to photograph where your wires go depending on the board and remove it from the stove. To fix a board we're using today are a desoldering iron with a vacuum pump. There are many different styles you can use, and this one's cheap and effective in our opinion, and I do have a link for it. I also have a wire brush to deal with oxidation or damage from the board, and then a Weller soldering iron, which we found works really well for our primary soldering iron. And then finally we have the relay, which will be board specific, and it could vary from board to board, even within a Frigidaire stove. On the board itself, there are small plastic tabs that hold the board into place that need removed either with a screwdriver or pulling on the plastic housing to release the board. It's safer to use a flathead driver, but we do this often enough just to pull and release the tabs by hand. When the board is released, we want to look for damage as a culprit on the physical board, and this one's very easy to spot. You can see that one of the holes on the board where the relay is has all of its solder connection burnt up, and guess what? The relay that is damaged is the bake relay, which of course handles triggering the bake mode on this stove on and off. It's proof that the relay is what needs to be replaced. You can also see heat damage on the other side of the board, but it should be okay in this situation. You want to look at the relay and where the damage corresponds to on the board, and then purchase and replace that relay. You can typically get these relays online, and I'm going to try to have a link for it in the description. To make sure you get the right relay, you should just have to look at the numbers on the model and then punch that in to find the correct one to use. The key numbers are voltage and amperage on the relay, as well as how it looks like it's routed within the system. Sometimes you can find a substitute relay by simply looking the numbers up as needed. To begin with the repair, we want to identify and desolder all the points on the relay that remain attached to the control board itself. In this style, there are 5 points on the board, and Jeff, one of my coworkers, is slowly working through the points with the $20 desoldering gun that we use at our shop. What this desoldering gun does is it heats up the solder around the relay, which lets you then press the button on the vacuum pump to suck the solder away from the relay to liberate it, and we have to do this on each of the 5 relay pins. This can take some time to fully desolder every connection, but eventually over about 2 or 3 minutes, the relays can be fully removed from the board. Once you have the relay fully removed, we use a wire brush on the board to remove any dark or blackened spots from the board that have oxidation to make sure that the electric's going to work on the entire board. If the silver trace has been ruined, you can resolder to create a new path, but that's going to be for another video because we didn't need to do it in this particular fix. When you have everything cleaned, you're going to slot the new relay into the board, and typically to secure the new relay, we're going to use some masking tape to hold it against the board solidly because you want the relay to be as close and flush to the board as possible when you resolder the new relay into place. Finally, you're going to use your solder and soldering gun to put the new relay onto the board and attach it. Remember, we're focusing on the board repair rather than how to do soldering because there are 1,000 other YouTube videos on how to solder correctly and improve your soldering skills, and I suggest watching a few of those videos before you take this on. This video is again about the tools and how to actually do this kind of fix. But we do plan on doing that in the future. We just happen to have this board that needed fixed today. Also, I apologize for this being blurry on the soldering part of this video. I'm using a newer camera and I'm still getting used to how to use the autofocus and have other people in the video doing my job normally. Now that we have the board fully installed and soldered correctly, we're going to do another pass with a wire brush. Jeff noticed during this repair that some of the solder didn't adhere right to one of the major points of contact on the relay. So he did apply some extra solder and move the current solder around just to ensure that it was going to be in good shape. You can see that the relays on the front of this when we're done do look different externally but are the same series and model. This is going to be common when you do board repair because the board's 10 years old, but the relay's brand new. Same model though. When you have the board fully repaired, make sure to put it back in the housing correctly, and then you're going to reinstall the screws to the control board back into the stove and then the wires. We had one tech remove the wires from the control board to get it ready for prep, and another one installed it, so we didn't know where the wires needed to go from a photo. So we ended up having to use the schematic to reattach the wires properly, And the schematic was on the back plate of the stove, and it's great to know where this schematic is because it can help you reattach the wires on any stove easily. It was behind the back plate, behind the control board. Now that everything's back in place, we just simply need to run the bake element and see if it now works without it being jumpered and everything in correct lacing. And in this case, everything has worked perfect, and we now have a working stove without a board replacement. The board on this stove would have cost $150 to $200, but instead we only had to use a $15 relay and about 10 minutes of time start to finish to get everything good and going. It's important to have the skill when you repair appliances because these boards can get very, very expensive, and the same techniques and tactics work on hundreds, if not thousands, of different board styles. I hope this introductory video helps you understand how to replace a board, and if not, I'm going to have many more of these videos in the future. Take care.